Welcome back to our chemistry flipped classroom. And today we're talking about naming covalent compounds. So we've spent a good amount of time talking about how we name ionic compounds. We began with binary compounds, both type 1 and type 2. And now we know how to name ionic compounds that contain polyatomic ions. And now we're moving on to how we name covalent compounds. So just a quick reminder that every chemical formula tells us the number and the kinds of atoms in a compound. And our molecular formulas, or those formulas of covalent compounds, they show the number and the type of atoms in the molecule. So when we talk about binary molecular compounds, we're talking about compounds that are covalently bonded together. That means that these are compounds between two non-metals. So everything we've been working with up to now has been an ionic compound, which has meant that it's a metal and a non-metal, or a metal and a group of non-metals. But here we're talking about two non-metals, and this is how we know when to use this convention. So if you're looking at a formula and you're trying to decide how you should name it, you want to look and see, do I have a metal or do I have only non-metals? And if you have only non-metals, then we're going to follow this naming convention. So the first element in the formula is going to get named first. And usually you'll see that this is the element that is farther to the left on the periodic table. It is the element that is less electronegative. So this first element keeps its element name. If there's a subscript on the first element, it gets a prefix. If there's no subscript and it's a 1, it doesn't need a prefix. The second element, of course, gets named second. But just like when we were learning to name binary ionic compounds, we're going to change the end of the element name to IDE. So it's going to be an "ide" suffix. The second element always gets a prefix that tells us how many of the atom there are. Even if there's 1, it's always going to get a prefix. And on that prefix, if the second element begins with a vowel, we're going to drop the O or the A of the prefix. So let's talk about these prefixes. So the prefixes that we use when we're naming molecular compounds are numeric prefixes. They tell us how many of that atom there are in the compound. So the prefix for 1 is mono. The prefix for 2 is di. The prefix for 3 is tri. These should all seem very familiar to you. When we get to 4, it's a little bit different. It's not quad, but tetra. So you can think of this kind of like the game of Tetris. That's all those little squares, and every square has 4 sides. So tetra means 4. 5 is penta. 6 is hexa. This should be familiar to you from your hexagons in geometry. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So we're going to use these prefixes to name our binary compounds. If the subscripts, and we're going to use those prefixes to indicate the subscript. So as an example, we have P2O5. So we're going to name phosphorus first. And since it has this subscript of 2, we're going to begin by saying diphosphorus. And then because our oxygen has a subscript of 5, oxygen, we're going to change from oxygen to oxide. And we're going to add the prefix of penta. So we have diphosphorus pentoxide. And this is where that idea of dropping the A, because the second element begins with the vowel, comes in. The second one should look very familiar to you. We're going to name carbon first. Now, because carbon has a subscript of 1, it doesn't need a prefix because it's the first element and there's only 1 of it. And then we're going to use a prefix of 2 to indicate this, of di to indicate this 2. And we're going to name this carbon dioxide. Now here's an example. We have the same 2 elements, but we have different subscripts. So here we had carbon dioxide in the CO2, carbon dioxide. Here we have carbon Well, we have only one oxygen, so this is carbon monoxide. And our last example, we have N2O. So we can see that we have a 2 on the nitrogen. So we're going to start with dinitrogen. And then we have only one oxygen. So we have monoxide. And again, we've dropped that O on mono. So it's monoxide, not monooxide. So you can see that even when we only have one of the first element, carbon here and carbon here, we do not use a prefix of mono on the first element. But if we have only one of the second element, then we do use the prefix of mono. So as before, here are a few for you to practice with. We have carbon dioxide, carbon monoxide, diphosphorus pentoxide. So I'm going to have you pause and write down the compound formulas, and then we'll go to the next slide so you can check your answers. So now that you've unpaused, check your work. We should have CO2, CO, P2O5, N2O, SiO2, CBr4, SO2, PBr5, ICl3, Ni3, and N2O3. And I want to point out something important here. This is one that students frequently get tripped up on. This SO2, this is a molecular compound. It does not have a charge. So this is not sulfite or hyposulfite. Then it would be an ion and it would have a charge. This is simply SO2. This is sulfur dioxide. Okay, now we have formulas and we're going to go to names. So again, I'm going to have you pause the video, practice writing the names from the formulas, and then check back to see if you're correct. So we have dinitrogen tetroxide, we have sulfur trioxide, we have nitrogen monoxide, we have nitrogen dioxide, we have diarsenic pentoxide, we have phosphorus trichloride, carbon tetrachloride, dihydrogen monoxide, sorry, that's dihydrogen, not dinitrogen. And we have selenium hexafluoride. I hope this has been helpful. As always, I look forward to seeing you and answering your questions. See you in class.